So I'd like to talk to you today about a new facility that we have at the university. We call it the Holodeck. It's the world's largest spatial augmented reality lab. So I want you to think about this. How do you design a fridge? What's the process to design an operating theater? And what's the process to design a command center in a submarine? So how do you do this? Well, the problem is you have this big design space. So on one side, you have virtual information. And this can be presented as CAD drawings, virtual reality, large projections like this. So you're living in the virtual world. Well, eventually, you have to live in the physical world. And you're going to make some sort of prototype. But for these large objects, it's quite expensive to go over here into the physical prototype. And with submarines, as I'm understood, they will actually make a physical prototype, but very late in the process. So what we want to do here is bridge the gap, and that's what the UniSA Holodeck does. It allows you to dabble in the virtual space and in the physical space at the same time. And the reason you want to do this is that when you design something large, one-to-one, is people innately have a problem looking at a design, figuring out what it looks like, and what is it full scale. So it's like designing your kitchen, but you can only look at it on a small little map. And you can get an idea of it, but only when it's installed that you actually understand what it's going to fully look like. And that's why you go to showrooms, and that gives you the one-to-one. So we're going to use a technology called augmented reality. So it's kind of like special effects in movies. And so what you're seeing here is you're seeing some real things, the actors and some of the sets, and it's superimposed with and registered with some graphical information. Now that particular scene where they're fighting in this third movie, this scene here took 1 year to make. Literally, it took that long to put this scene together, this 160-second scene. Okay, what we're trying to do is in real time. It won't look as good as this, but it's a combination of both these things. Okay, so virtual information superimposed, registered with the physical world. Okay, so you can present this data in a lot of different ways. What I'm going to talk about today is using projectors to do this, but you can use head-mounted displays, which are goggles that allow you to see the physical world and project into it. In fact, there's a picture of our goggles on the RI Oz, that's our work there, or you can use a mobile phone. And you've seen a lot of hype's been about AR apps on this, and I have an AR app for this, which is from the Commonwealth Bank. And so I can walk around there and it will float information above a house and tell me how much it was last sold for. So you're registering virtual information in a physical space. Okay, so now we want to do this with projectors, or we call this spatial AR. So this is how you do it in 5 easy steps. First of all, you have a model. In this particular case, we built it out of wood, but you could build it out of foam board or anything. So either you build a model to spec, or you have, like we have a toy car, which we scanned in. So you have a physical model, and you have a virtual specification for it. Step 2 is you make a virtual object of it, which is the same shape and size. In this case, we're just looking at the front of it. You get some textures that you want to paint on this. So we can have multiple ones and look at different skins. Then we have to determine the pose, which is the position and orientation of the projector relative to whatever we're going to project against. We apply the secret sauce, which is our software we've developed in our laboratory. And then you get perspectively correct images on here. And what this allows you to do is you can emulate what a control panel is going to look like. And the great thing about this is you can use all your current 3D packages. So we use things like Maya, Inventor, Studio Max. We're working with Holden, so we're getting their 3D models out of their systems. So you build it up in the normal way, and then you can project it against this. And so what you do is you get this kind of passive haptic nature. You can touch it. Okay? And what this allows you to do is you can sit somebody down in front of this, and they can actually operate the control panel. The thing is, we build these I built 3 of these things, or hired somebody to build it. It cost me $200 to build these things. It's cheap. You already have the virtual information because you're designing with it anyway. Okay, so let's talk about the holodeck. So this is a new laboratory that's built at the Uni. It's a physically large room. It's 14 meters by 8.5 meters by 4 meters tall. You literally can drive a car into this. Okay, we have 44 projectors, so we can support a large artifact that we can emulate. Massive computing, cameras, external load-in, so we have a door that you can bring in and out whatever you want. So the idea is that you could build a control room in here, or you could design a fridge, an operating theater, anything inside this and visualize it. Okay, so we're interested in doing command and control rooms, partly because they build a lot of them here. And so the idea here is that if you see two of my students, they're in front of this control panel. And what you can do is you can configure these, and then you can put teams inside here and then say, well, how does the team operate? So how does the team talk, collaborate? You can put simulators behind it to stimulate them, so you can do wargaming. You can say, what does it look like to have the configurations of all back-to-back, side-to-side, and you can move them around. So what we can do when you're doing the design is we can either show you the design, you can physically move around the controls on each of the panels, you can physically move around the panels, you can swap things around, and so it's a very flexible manner that the stakeholders can understand the design. One of the things when you have these high-value artifacts that you're trying to design is it's very difficult for people to say, yes, go ahead and build that. Because it's very difficult to understand what that control room is going to look like when you're just looking at a drawing. And so what this allows is mere mortals and not designers to understand these three-dimensional spaces and the relations. So you can bring in the commanders, you can bring in the submariners, or the politicians, or the people from DMO, and then they can understand the design. It's all about ownership and understanding the design. So the benefits that you get from this. It's a natural way of viewing. Like I said, it's unnatural for us to look at a CAD drawing, reconstruct it into our head, and then visualize what it is in 3 space. Okay? It allows easier buy-in from stakeholders. They understand what the design is, and you can move forward in the design process. You can do early measurements. So what happens is you can sit people in front of these command centers. You're going to say, are we making people reach in an unnatural manner? Are we making people do operations that are detrimental to their health? And we can hook simulators up to them and do wargaming with the new technology. So what you can do is if you have a 10-year, 15, 20-year project, instead of waiting 10 years into the project or halfway through the project, very early on you can start looking at these issues. Because you already have the data, you're designing it from the beginning, you're designing things. Or you use this as a design tool. Currently, people, when they want to design large things like work cells, or some companies actually do, is they get cardboard boxes, stick them where they think it should be, and then they just draw in pencil or magic markers. This allows you to do it in a much more detailed manner. So we're not just doing this because it's a fun project. We're currently working with Holden, and they're using this to do in-situ information for manufacturing of assemblies. We're working with Intel using projector-based technology to help maintenance tasks. We're collaborating with Jumbo Vision, a local South Australian company, for designing control rooms. So today we have a facility that can actually help people design things today. So whether you're going to design a photocopier, or you're going to design a kitchen, or you're going to design a visualization control room, or a refrigerator, or an operating theater, or submarine control center, we have tools that enable you to help you to do that today. So for the industrial partners in the room today, what we'd like to do is, if you have problems that you want to design large artifacts, we would like to talk to you about possibly collaborating to build. Or you have technologies that help with the design process, we would like to incorporate those into our process. So thank you very much.